So we're starting with multiplying with decimals, and it does have almost the same steps for multiplying as with normal numbers. As with adding and subtracting, we don't write our question out like this. It'll probably be given like this, but we write it out in the proper algorithm, which is, because it's times, it doesn't matter which one's on top. So let's have the most digits on top, 2.57 times, and this is the one where I don't need to have decimal points lined up. Instead, I'm right justifying. That is, all the numbers are pushed over towards the right, so my 3 goes there. A line goes underneath it. And we multiply exactly the same way we would if there wasn't a decimal point there. So we do 3 times 7 is?
21.
21, 2 digits. Which digit do I put down?
1.
The 1, the units, and the 2 goes up there. Now that's not 25, it's just a 2 that's going to get added on later. 3 times 5 is?
15.
Plus 2?
17.
Put down the 7, carry the 1, ignore that decimal point. 3 times 2 is 6, plus 1.
7.
Now, there's a trick to working out where we put the decimal point. And there's 2 suggestions that I want to make. One is, just make a bit of a guess. 2.57, let's say it's pretty close to 3. 3 times 3 would be?
6 on.
9. Our answer should be pretty close to 9. It definitely shouldn't be 771. It shouldn't be 77.1. It should be 7.71. So first up, it's a really good idea to make a quick guess. Just get an approximation. But the way we do it is we count how many digits there were after a decimal point in the question. There were 2 digits after a decimal point in the question. We want 2 digits after a decimal point in the answer. So there's 2 ways of working out where that decimal point goes. So let's write that down really quickly.
What's that noise? That's a noise. Something.
There's a noise. Put up with it, please, and write this down.
It's above my head.
Count the digits after the decimal point in the question. That many digits after the decimal point, I'm abbreviating there, in the answer. So that's the only difference between multiplying just whole numbers and multiplying with the decimals. Just have to work out where the decimal point goes. So our second example, set it up in the algorithm. And remember, we're right justifying. We're pushing things up against the right-hand side. Line goes underneath. Now here's where I'm multiplying by a 2-digit number, so you will remember. I'm going to have to do 2 sets of multiplication. Very quickly through this one. 6 times 3 is 18. Put down the 8, carry the 1. 6 times 1 is 6, plus 1 is 7. 6 times 4 is 24. Now when you get to the last number, if it's a 2-digit number, you can just write both digits in like that. Now I get to the 9, but what do I have to do first?
Add a 0.
Put down a 0 to say that I'm multiplying by the next place over. 9 times 3 is? 27. Now we've already got a 1 up there, And I don't need that one anymore, so it's a good idea to write your 2 over it so we don't get confused. 9 times 1 is 9, 10, 11. 9 times 4. Oh, come on, people.
36.
36 plus 1, 37, and again I can write that down there. Now when I've had to multiply by 2 digits, what do I have to do now?
Find out what the decimal place is.
I don't find out where the decimal place is, I add first, remember? Because I've got 2 sets of numbers. I did times by the 6, then times by the 9. 8 plus 0, 7 plus 7, 14, put down the 4 and carry the 1. 1 plus 4 plus 1 is 6, 9, 3. Now our 2 methods for working out where our decimal point goes. This is pretty close to 4 times 10. So my answer should be pretty close to 40. Where's that decimal point going to go?
After the 9.
After the 9. And do our check. How many digits in the question?
2.
1, 2, 3. 1, 2, 3. We were correct. We've got our answer. So we might stop there with the multiplying and do dividing as a separate example.